The distances in space exceeds our perception. From an astronomical point of view, our moon is considered to be at our doorstep. But takes at least 3 days to reach, even with the help of the Saturn V rocket, one of the most powerful vehicles ever produced by humanity. On the other hand, going to Mars takes an average of 6.5 months. It is not suitable for us humans to travel for months in a space capsules, that is no bigger than a room in the endless void. It may cause lots of psychological problems. In addition to the psychological impact on humans, long-term exposure to cosmic radiation can lead to various health problems, including cancer. To lower the risks of the space travel, and make it safer, we must shorten the travel time. And the best candidate we have to get to our destination faster than any other system is nuclear rocket engines. Welcome to the spaceship Earth. In this video, we will talk about nuclear rocket engines, how they are made, their advantages and disadvantages. The main idea of moving a spacecraft is getting the most energy out of the rocket engine's exhaust with the least amount of mass. In liquid-fueled rocket engines, currently hydrogen is the most efficient fuel we have. With the energy obtained from burning hydrogen, we can accelerate a rocket. However, we need another chemical substance that will act as an oxidizer alongside the fuel. One of the biggest problems with chemical rockets is that the required oxidizer is heavy and must be carried in the rocket throughout the entire mission. Another problem caused by the oxidizer is that it reduces the speed of the rocket by slowing down the speed of the exhaust gases. Hydrogen is a very light substance, but the oxygen we use as an oxidizer is 16 times heavier than hydrogen. The fuel, which reacts with the heavy oxygen to produce water vapor after the reaction, is usually expelled into space at speeds of around 4,900 meters per second from the nozzle. To increase the speed of the rocket, we need to increase the speed of the exhaust gas. For this, we need to get rid of the oxidizer, which makes the rocket heavier. Also, we need to find a lightweight but effective way to speed up the hydrogen and send it from the rocket at high speeds. When we talk about low mass and high energy, nuclear fission is the best technology we have. The idea of harnessing this high energy density began to circulate in the minds of researchers from the 1950s, when both space exploration and the atomic revolution began. At a time when it was imagined to make every means of transportation, from planes to cars, work with nuclear energy, it was not unusual for rockets going into space to also be turned into nuclear-powered vehicles. During this period, two main designs were initiated for this purpose: the NERVA project carried out by NASA and the RD-410 project carried out by Soviet Russia. In the nuclear thermal rocket engines, liquid hydrogen is heated with the energy emitted by the fuel rods made of uranium or plutonium. And thrust was obtained by the exhaust gases at very high speeds from the engine nozzle. To give an example of the high energy capability of nuclear engines, a nuclear thermal rocket engine loaded with plutonium can speed up the hydrogen at speeds of up to 9,800 meters per second, making it almost twice as fast as the speeds produced by conventional liquid-fueled rocket engines. Nuclear engines provide significant advantages for spacecrafts leaving from low Earth orbit, primarily due to their high-speed capabilities. Thanks to the high-speed capacity they provide, travel times to the Moon, or Mars can be reduced from the current 6.5 months, to as little as 3 months. Despite the risk of radiation sickness for astronauts working on these type spacecrafts, and the danger in case of reactor accidents, many projects carried out before, and some companies still working on systems like NASA's NERVA engine DISGIN approved for human flights. However, the RD-410 engine developed by Soviet Russia was made more efficient than NERVA, but it had not yet met the safety conditions required for human flights. Despite their advantages in the mid-1970s, as the space race slowed down, nuclear engine projects were abandoned due to their costs and potential risks. And after that, US and Soviets returned to liquid-fueled rocket engines. Although, projects such as Copernicus, designed for manned flights to Mars in the 1980s and 1990s, were proposed with nuclear engines. But they were rejected by the American Congress, because did not want to spend money on space. Similarly, after the collapse of the Soviet Union, the Russian space agency Roscosmos, which was left without resources, cancelled nuclear thermal engine and manned missions to Mars projects. Since 2010, countries, including China, have been working to shorten travel times to the Moon and Mars using nuclear rocket engines. For example, the Defense Advanced Research Projects Agency, DARPA, of the United States signed an agreement to develop and test a new nuclear thermal rocket engine, using technology and materials developed by General Atomics. The nuclear engine to be produced is planned to be used in a cargo vehicle for regular transportation between low Earth orbit and the Moon. In addition to this, NASA and the Russian space agency Roscosmos are working on spacecraft designs that can use nuclear energy and electric propulsion systems together. NASA is working on high-power, but relatively small nuclear reactors. The goal is to provide power to spacecraft, and provide energy to future lunar and Martian bases. Roscosmos is currently working on a spacecraft that will use advanced Hall effect motors, powered by a nuclear reactor. It is said that this spacecraft, which can reach the Moon from Earth in 20 days, can operate for a long time without refueling. If the system successfully completes the trials, it is estimated that more advanced versions will be used in unmanned research missions to Mars and the asteroid belt. Nuclear energy is used worldwide in many fields. Because it does not require continuous refueling, and can meet high energy demands, it is actively used in both military and civilian ships. In space exploration, nuclear rocket engines can provide the high amount of energy needed to overcome the distances to planets or moons beyond Mars more quickly. This can reduce the long travel times required to reach the asteroid belt, Jupiter's moons, and Saturn's rings, and allow spacecrafts to operate at distances where the Sun cannot provide energy. Furthermore, these engines can also provide us with the ability to reach the distant realms of the solar system. Reducing travel times of human or unmanned research missions to the asteroid belt, Jupiter's moons, Saturn's rings, and beyond can be achieved, thanks to the high energy density of nuclear energy, which is currently the most ideal technology at our disposal. Thank you for joining us on this spaceship Earth. If you found our video useful, please like and share. To stay updated on space and space technology news, please subscribe to our channel.